Good afternoon, everyone. My name is Dimo. The topic of my class project is motion correction of propeller MRI. Why I choose this topic is because I'm interested in motion correction in imaging, and I hope that I can learn more techniques in this area through this project. Therefore, I set three goals in doing this project. The first one is to briefly know some methods of motion correction in MRI. The second one is trying to implement several methods of motion correction in MRI by myself. The third one is to know more about common ways or details in imaging processing. I did this work exclusive in ee591 class project. Why we need motion correction in MRI? Here I will use this image to show the reasons. As you can see, the shape of your target is quite in a mess. It's very difficult to see its characters clearly. If this was a real MR image, how it can be used to make a diagnosis? Therefore, we need some methods to correct the image to a desirable image. In most cases, these kinds of artifacts are created by patient's motions during the scanning. So, we need motion correction to fix this problem. What are some existing solutions and why are the solutions adequate? The best one should restrict the patient's motion during the sequence. However, it's hard to do because you cannot stop the heart beating for a while. Therefore, we should explore ways in imaging processing. Imaging processing focuses on two domains, case-based and image domain. For case-based motion correction methods, they have propeller, chalice. One motion correction method during MR scanning through the automatic rescanning of severely motion subjects. One motion correction algorithm using the case-based phase difference of orthogonal acquisition. These algorithms require longer acquisition time because of the extra data acquisition process. For image motion correction methods, they have high-resolution algorithm for cardiac MR image. It uses registration or averaging of the image to improve SNR. Use inverse interpolation by estimating the path-to-path motion. Use a slice-to-volume registration for motion estimation in the fetal MR brain. Use iterative path-to-volume registration process to minimize the motion artifact. Most of these methods use registration for motion estimation. After computing the motion parameters, missing data are interpolated. In this project, I choose propeller MRI as my project topic because it has already implemented in real MR machine. In propeller method, it has 6 main steps: data collection, phase correction, rotation correction, translation correction, correlation weight, and final reconstruction. For data collection part, propeller data are collected in case-based in unstrips, each consisting of L parallel linear trajectories, corresponding to the L lowest frequency phase encoded lines in any Cartesian-based data collection method. For phase correction part, is to make sure that the point of rotation is the center of case space. For rotation correction part, we know that the rotation angle in imaging domain is the same as the rotation angle in case-based domain. Besides, we need to choose a frame has the strongest correlation with average magnitude as reference frame. Therefore, if we consider the magnitude of each strip, it's easy to find out the rotation angle. to the reference frame. For translation correction part, do a convolution of the average complex dataset and the complex dataset for the unstrip within the central circle part. Then perform a Fourier transform and find the peak magnitude. Translation in x and y directions can be estimated through the position of the peak magnitude. For correlation weight part, just follow the formula it provided. And the final step is to reconstruct the corrected data. For the PCA method, just change to use PCA to estimate the displacement in rotation correction part and the translation part. Here you can check the results. The first row image just has rotation artifacts. The second row image just has translation artifacts. The third row image has rotation and translation artifacts. Here are the results for PCA correction. Also, the first row for the rotation artifact, the second row for the translation artifact, the last row is for the translation and rotation artifacts. As you can see, the result of motion correction of propeller MRI is quite well, but the result of motion correction of PCA is not so acceptable. The challenges I met in this project can be described in two aspects. One is to understand the concepts in this paper. The steps described in the paper always seem to be reasonable and their corresponding formulas seem to be easy to implement. However, once you want to follow the steps they mention, you will find many difficulties they didn't mention in the paper, and you have to figure it out by yourself. At the beginning of this project, I chose a paper has a few citations. I emailed to the author to ask him some questions in the paper, but he didn't reply me, so that I cannot follow his method anymore. The second one is to implement the method and get a good result. It needs time to debug the code. It needs time to figure out the error it shows. In all, if you want to get a good result, you have to try different ways even though it didn't tell you in the paper. Each specific case will have its own method to get satisfying result. You can find it out by testing your code again and again. For example, I found that using PCA to do the motion correction is not suitable because its approximation has a wider range of error. The lessons I learned in this project. The first lesson I learned is that do not make a decision in a hurry without considering your time and ability. For example, I tried to implement 3 methods at first. However, I finally just implemented another 2 methods because these 2 seem to be possible for me and I can have more time to prepare for my job's interview. The second lesson I learned is that there are many methods of motion correction in MRI. On one hand, you should clearly know the principle of MR imaging so that you can know which step can be applied the motion correction method. Of course, you should know math quite well. On the other hand, the image registration is a large part in motion correction. The third lesson I learned is that you know your interests already, so that you should spend more time on the work you are interested in. Actually, I would like to do some programming in web design or Android or iOS, rather than to write code in MATLAB. Thank you. That's my presentation.